Hello everyone, I'm Maria Sushmayas, Assistant Professor from Department of EEE ATMEC. I welcome the students of EEE to the demonstration session of experiments in the lab for System Analysis 2. Today we will analyze the experiment titled Calculation of Penalty Factors and Solution of Coordination Equations for Economic Operation of a Power System using Software Package. Here's the question. Cost equation and loss coefficient of different units in a plant are given. Determine economic generation for a total load demand of 240 megawatts. Here we have two such tables. The first table is indicating the cost equation of the three generating units, and the second table is giving the information of beta coefficients. And here we have the three cost equations, namely C1, C2 and C3. Let us look into the aim. It is to determine economic generation for a given load demand. The package used is MyPower. Now let us look into the method using which we are going to solve this problem using the software package MyPower. Here there is an icon MyPower. Double click on it. Click on OK. Click on MyPower. So let it be in the mode super user. Click OK. Click on Tools. Choose the third option, Economic Dispatch by Beta Coefficient. So here we have the data entry table in which we are supposed to enter this data. First we have to create the path for saving our file. Click on New. So right now I will be choosing desktop to create a path. Create a folder. So I have given the folder name as beta coefficient. Double click on the folder. Give the file name without space. I am giving this as problem P1. Click on save. So here you can find the path. Now fix the total load demand as given in the question. So write it as 240. So number of generating units are 3. Put the number as 3. Now give the details of cost equation. Select each generator. Go to the generator details and fill this detail. Now choose generator 1. So let P minimum be 0. You can check the range here. Maximum is 100 and schedule we will make it as 90. Likewise, let us fill the details for generator 2. Minimum is 0, maximum is 100. So this is the data for generator 2, and schedule power we will give it as 90. For generator 3, minimum is 0. Generator 3, we have to check this row. Maximum is 100. Schedule, I am giving it as 90. So now, go to generator 1 and fill the coefficients C0, C1 as well as C2. So C0 is indicating the constant in the first equation. I have chosen the first generator. So we have to concentrate only on the first equation. So this is C0. C0 will take the value of 800. C1 will get a value of 20. C2 will get a value of 0.05. Let us enter this. 20 and C2 is 0.05. Similarly, select generator 2 and fill the coefficient values. Cost equation. C0 is 1000. C1 is 15. And C2 is 0.06. So these are the respective coefficients of the cost equation, and C0 is indicating the constant. Choose generator 3. C0 is 900. Make this as 900. C1 as 18 and C2 as 0.07. So by this we have completed entering the details of generator Now in the next part we have to fill the details of beta coefficient. For this we have to refer this table of loss coefficient. So it is a 3 cross 3 matrix. So let us start filling the elements. Choose row 1, column 1, and this is identified as beta 11 or B11. So enter the value as 0.0005. Click save for each entry. Now make the column as 2. And now beta 12 is 0.00005. Click save. For column 3, beta 13, enter this value 0.0002. Click on save. So now choose second row. First column 2 1 is same as 1 2. You can check here. So enter the same value of 0.00005. Click on save. Column 2 row 2. So it is beta 22. So beta 22 is 0.0004. Click on save. 2 3. 2 3 is same as 3 2. 3 2 is same as 2 3. You have to enter the value of 0.00018. Click on save. Okay, so we have verified this. Now choose the last row 1 with the column 1. So beta 31 is same as 13. You have to enter 0.0002. Click save for each entry. 3 2 is same as 2 3. So we have to enter this value of 0.00018. Save. And last 3 3. So 3 3 we have to enter this 0.0005. Click on save. So all the entries should be in per unit. So beta is to be checked for per unit. Now make the initial lambda value as 5. By this we have completed entering the details of beta coefficients. And now let us save the entire data entry of this particular problem. Now click on execute to see the result. And here the first part is indicating the beta matrix and second part is indicating the scheduled power for 3 generating units, and according to the random data entry the cost of generation is 8,928 rupees. So this is regarded as initial cost. So randomly we have taken some 90 megawatts of power is being scheduled for each generating units, and this is the respective cost. If this cost is summed up, we will be getting the total cost of generation at the initial level will be 8,928. Once everything is processed, we are able to reach the final cost of generation, and you can check the iteration count. It has ended at 252. Now you can check the final cost of generation at bus 1 or first unit is rupees 2,538 and it is generating 73.4 megawatts of power. Likewise, unit 2 is generating 100 megawatt of power, and last unit is generating 66.7 megawatt of power. If we are going to sum up this, we are going to get the total load demand of 240 megawatts, and the total cost of generation is found to be reduced. It is rupees 8,050, which is less compared to the initial cost. Initial cost was found to be 928. So by this we can sum up that we are having the economic generation. Thank you.